What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And we are continuing today with the SAT April 2017. Just making sure the audio is working and we're good here. Good to go. I'm still waiting to hear myself.
What's up,
Yeah, there we go. Audio's good. All right. What's up, Mohammed? Fact, yeah, it's not in real time. There are some stream delays, but it's still pretty close. What's up? Any tips getting 5 to 6 wrong in calculator? Well, my tip to you is to watch this stream because you're going to see my strategies and the way I approach the problems, and that hopefully in and of itself should be helpful for you. Maksu, what's up? What's up? What's up, Chris? All these guys taking this test hopefully this weekend and maybe even some in October in the following week. So let's just keep it going and keep it rocking. Zoe, I know you're taking your test tomorrow, so best of luck to you. What's up, Lucas? What's up, Texture? Honey, how's it going? Tiff, Jordan, what's up? Don't recognize you, but welcome to the stream. Maybe you have been here and just haven't been saying hi. All right. You guys know the drill. I'm taking this for the first time in real time. At least I believe this is the first time. Like, some of the questions yesterday look kind of familiar, and I'm like, but the most of the tests didn't. So I'm wondering if maybe those tests have been used elsewhere in other resources. I don't know. But anyways, Yasama's excited. All right. What's up, TJ Sunimi? I believe I said that right. Bash, good luck for you tomorrow. Ayush, good luck for you tomorrow. Shania, that's amazing. I'm so happy to hear that. Yeah, you're welcome, Zoe. Okay, guys, here we go. We've got a 55 minutes on the stopwatch. We got the calculator queued up. Oh, and Friday it's going to be the day before the test for a lot of you, and I might not even be able to stream because I'll just have moved. But after Friday, I'm getting, I believe, the world's fastest Wi-Fi or something like that. So the fiber optic cable. So these streams should be even better, hopefully, for everybody out there watching. Okay. What was I going to say? I think that's it. All right. Last but not least, let's get this thing going. Good luck, Mohammed. All right. We're going to start. Oh, yeah, and please, if you do like these videos and do support the channel, if you could click that like button, I really appreciate it. It helps the channel tremendously and helps spread the word to other hungry and eager students like yourselves. Here we go. We're going to start in 3, 2, 1. Let's do it. Whoops. If m equals 3, how much greater is 10m than 6m? All right, 10m is 10 times 3, which is 30. 6m is 6 times 3, which is 18, and it's a difference of 12. Numero 2, the temperature in degrees in Celsius C of a hot object placed in a room is recorded every 5 minutes. Temperature of the object decreases rapidly at first, then decreases more slowly as the object's temperature approaches the temperature of the room. That looks like A, but we'll come back to that. Which of the following graphs could represent the temperature? This is a constant increase. This is an increase. This is a gradually decreases and decreases faster. That's not what we want. It says decreases rapidly, like boom, it drops a lot, and then slower. Okay, and it looks like the temperature of the room is about 30 degrees. All right, number 3. Which of the following values of x is a solution to the equation above? Okay, let's solve. Square both sides. X minus 2 squared is, of course, x squared minus 4x plus 4, right? I'm foiling, so I'm not just squaring that. Square that side, it's x plus 10. Zero product rule, subtract x and subtract 10. So I got x squared minus 5x, right? Negative 4x minus x, negative 5x. 4 minus 10 is minus 6 equals 0. Factor. Let's get rid of this guy. Equals 0, and I've got x minus 3 minus 2 because negative 3 times negative 2 is negative. Oh, wait a minute. My bad. That's wrong. Minus 6 and plus 1 because negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. My two solutions are positive 6 and negative 1. Oh, wait a minute. Oh, one of these is extraneous. My bad. I'm rushing. I believe 6 is the answer. Here's why. 6 minus 2 is 4. 6 plus 10 is 16. Square root of 16 is, of course, 4. So that works. Negative 1 will be the extraneous. Negative 1 minus negative 2 is negative 3. Negative 1 plus 10 is 9. Square root of 9. Yes, you're going to say it's plus or minus 3. But in these questions, we're only taking the positive root, not the negative root. 3 is not equal to negative 3. It's extraneous. Number 4. Last year, 800 students attended the career fair at West High School. This year, the number of students who attended the career fair increased by 5%. So let's do a 5% increase of 800. So the 5% increase multiplied by 1.05, right? 0.05 is 5%. 1.05 shows a 5% increase, and we got 840. Done. Let me just make sure I didn't misread it. Students attended this year. All right, cool. Number 5. Okay. nutritional information for 1 ounce serving of seeds and nuts. Pecans, pistachios, so they get calories, fat, and protein. Calories, fat, and protein. All right, great. How many more grams of How many more grams of protein are in 1 pound? By the way, this is 1 ounce. There's 16 ounces in a pound. And they do say that. Good. In 1 pound of pumpkin seed, I'll put a little thing there. Then 1 pound of pistachios. So how many more grams of protein? So protein. So 3 times 16 is 48. 8.5 times 16. I'm just going to do the calculator. 8.5 times 16 is 136. All right. So 136 minus 48 is 88. I'm happy with that. Protein, right? Protein, yeah. I could have also taken the difference and then multiplied by 16. Like 5.5 times 16 is, of course, the same thing. But I'll show you. 88. All right, next is numero 6. We got to keep this here. Lionel purchased 1 pound bags of each of the 5 seeds and nuts shown in the table. Of the following, which best approximates the average number of calories per bag? Got it. Okay. So 1 pound of each, so it's... do we need the 16? We can multiply by 16 at the end. So it's 1... No, let's just do it. It'll make more sense. So, of course, 1 pound, so it would be 16. Let's do parentheses to make sure there's no mistake. 16 times 198 plus 16 times 80 plus 16 times... Oh, shoot. 16 times 159 plus 16 times 166. Make sure no mistakes with the numbers because that will be a dagger if I mess it up. Plus 16 times 185 equals that. And then, of course, we divide by 5 because there's 5 bags. And we get 2521.6, which is about that. Oh, wow. Actually, that could have been a lot easier. I didn't realize these numbers were so far apart. But anyways, yeah, because you can kind of figure out that it looks like the mean's about 160, I'd say, somewhere in there. And then that times 16... Wait a minute. 160. Yeah, am I saying that right? 160 times 16. Yeah, 2560. So see, that could have right there could have been easier. Anyways, 7. A pool initially contains 1385 cubic feet of water. A pump begins emptying the water at a constant rate of 20 cubic feet per minute. So I see in the answers they did T for minute. Which of the following function is best? So it's 1385, and we're subtracting 20 feet per minute, or 20 times t. Which of the following function is best approximates the volume of cubic feet of the water pool T minutes after this. This we don't have to worry about. Presumably this will drain by 69 minutes, I guess. And we're good to go. Make sure to make any mistakes. Linear inequality or equation, sorry. At a snack bar, each medium drink costs $1.85, and each large drink costs C more than a medium. If 5 medium drinks, 5 times that, and 5 large drinks costs a total of $20.50, what is the value of C? How nice is that? I literally translate it as I'm reading it, and then it becomes really easy with the calculator. So 5 times 1.85 equals, so it's 925 plus, distribute, 925 plus 5C equals 2050. Add these guys together, that's 1850 plus 5C equals 2050. Subtract 1850 from both sides, 5C equals 2. Divide by 5, divide by 5, oops, divide by 5, sorry. 2 divided by 5 is, of course, 0.4. And we have our answer. Now let's double check. 0.4 would be C, so this would be $2.25. So 5 times that is 925 plus 5 times 2.25, and we should get 2050. And we did. We're good to go. Double checked, verified, boom, moving on. Kate bought a bus pass that had an initial value of $90. For every bus ride Katie takes, $180, the cost of one bus ride is subtracted from the value of the pass. What percent of the initial value of Kate's bus pass is the cost of one bus ride? So it's 180. We can do it like this. I could literally just do 180 divided by 90, put in the calculator, and then move the decimal over twice. Or we can use the percent proportion just for fun and cross multiply, and we'll get our final answer. So 90x equals 100 times $1.80 is 180 divided by 90 is 2%. Does that make sense? Yes, because $90, 90 cents would be 10 to 1%. 180 is double that, is 2%. Number 10, to determine whether residents of the community would vote in favor of a ballot proposal to use 100,000 of local taxes for additional playground equipment at a community park. Jennifer surveyed 60 adults visiting the park with their children during 1 week in June. Hold on. So this is one of the data collection. So Jennifer surveyed 60 adults visiting the park with their children during 1 week in June. And by the way, this is already biased because you're surveying people at the park about parks. She found that 45 of those surveyed reported that they would vote in favor of the proposal. Which of the following statements must be true? Because it's a biased sample. It's not about the sample size, but yes, no prediction should be made. Sampling method is flawed because you shouldn't be sampling at a park when we're talking about a park, because obviously people there are going to be those that like parks. It's not flawed. It is flawed. Wait, did I skip anything? No. Numero 11. This one. What is x squared plus y squared? This is very nice if you recognize this is a difference of squares. And I say if you can factor and you see a way to factor and you're confused otherwise, factor. So it's x squared minus y squared times x squared, plus y squared, right? Because that's a difference of squares and that's what it becomes. And this equals negative 15. Guess what? I know that this can be substituted in here. So now it's negative 3 times x squared plus y squared equals negative 15. I don't need to solve for x and y to do this. I just know that what does this equal? Well, it has to be 5 because 5 times negative 3 is negative 15. Boom, done. All right. A cable company recorded the percentage of households in the United States that had cable television from 1987 to 1997. So it looks like 0 is going to be represented by 1987. 10 is going to be represented by 1997, right? Because it's number of years since 1987. Scattered plot below X yeah. Okay, the line of best fit. Great. So it looks like percentage of households with cable television increases. Makes sense. And we're getting closer to 70, 80%, after that point. Which of the following is close to the equation of the line of best fit? So I see a y-intercept at 54. So it's this one. That's negative 54. That's a y-intercept of 7/5. And it looks like the slope of 7/5 is correct, but there's a 0 y-intercept. So nice. What is this? 13 only. Which of the following is the best interpretation of the slope of the line of best fit? So let's go back to this. Check it out. First of all, we already know the slope from our right answer, and 7/5 makes sense, right? I go up 7 to 61, and I go over 5. That seems about right? Go over 5. So there we go. And that means for the bottom number is the time, right? So if it's 7/5 for every 5 years, the increase, the number of people who own TVs goes up by 7%. That's it. So hopefully they left it in terms of 5 and 7. The actual increase in the percentage of households with cable television each year. Oh yeah, I can actually simplify that. So it's like 7/5, which becomes 1.4, right? Percentage of households with cable television. Yeah, so which is 1.4. It goes up by 1.4% each year. But let's double check these. Predicted increase in the percentage of it's not actual. They almost tricked me. Actual would be the real data points. Predicted is what a line of best fit is. Now, the actual increase in number of no, it's not number because it's by percentage. Predicted, nope, because as it said over here, percentage. All right. 14, a greenhouse owner purchases fertilizer in the 60-gallon drums. The fertilizer is mixed with water to make several batches of a solution. The fertilizer is mixed with water to make several batches of solution. Each batch of solution is made by mixing 3 quarts fertilizer with water. Wait, hold on. What is doesn't say how much water. Number of batches. So 60. Oh, it's not about the water. 60 gallons. So we need 3 quarts. 60 gallons, by the way, there's 4 quarts in a gallon, so it's 240 quarts. And we need 3 quarts for 1 batch. Maximum number of batches solutions can be made from 1 60-gallon drum. So it's 240 divided by 3, which is 80. Okay, 15. Tara rode her bicycle along a straight road from her home to a restaurant and ate lunch. Tara rode her bicycle along a straight. She then continued. So she's riding, and then stopping. She's chilling. Then she's eating lunch. Then she continued along the same road to a movie theater. Boom. Stops at the movie theater. Watches the movie for like that long. And then she returned on the same road after the movie. Tara's distance from home during the 4 hours. She was out showing the girl. How many total miles did she ride her bicycle? Okay. So she obviously rode 3 here. Another 2 here, to get there. So it's a total of 5. And then she rides 5 back, which is 10. And that's it. Make sure, because she goes 5 and 10. And then this is just the time. But that's she's 5 miles away, then 5 miles back. Numero 16. Ryan has 1,500 yards of yarn. He wants to knit at least 2 scarves and 3 hats. So at least 2 scarves and at least 3 hats. That's right. That's right. That's wrong. That's right. Okay. Each scarf requires 300 yards, and each requires 120 yards. If that's the following, okay. So we got 1,500 yards, which yards of yarn. So which means 300 times the number of scarves plus 100 times the number of hats has to be less than or equal to 1,500. Has to be less than or equal to the total amount of yarn that he has. That's out. That's out. That's the winner. 300S plus 120H is less than or equal to 1,500. Numero 17. And we don't have to solve, right? That's the nice thing. Michael performed an experiment where he tossed 2 coins, 1 dime, and 1 nickel at the same time. Recorded whether each one landed heads or tails. Results are in the table below. So 2 coins, 1 dime, and 1. So here's the dime. So he got heads. At the same time. So 27 heads, 26 heads, tails, 24 tails, heads, 23 tails, tails. Okay. For what percent of the tosses did the dime, and that's a total of 50, and 50 is 100. For what percent of the tosses did the dime Michael toss land on heads? Dime land on heads right there. We just have to read this 2-way table. And that's 27 plus 26, which is, of course, 53 out of 100, which is 53%. Numero 18. During a storm, the atmospheric pressure in a certain location fell at a constant rate of 3.4 millibars per hour over a 24-hour period. So 3.4 times 24. I'm just going to do it right now just in case I need it. So 81.6. Which of the following is close to the total drop in atmospheric pressure in millimeters of mercury over the course of 5 hours? So then, so they just want 5 hours. So I shouldn't have done that. So 5, it's fine though. 5 times 3.4 is 17 millibars. But now we want to know millimeters of mercury. And it says this many millibars equals that many this thing. So millibars to Hg has a ratio of 1,013 to 760. And now I've got 17 millibars is equal to how many Hg? Yes. Calculator for shizzles. 17 times 160. 760. Cross multiplying equals 1,013x. Divide by 1,013. 12.8 if we round up. All right, good to go. Numero 19. On its opening day, a car dealership had an inventory of 29 cars. Okay. During the first 6 months, 18 additional cars were purchased. And by the dealership each week. I don't know how to represent that right now. I'll just do it like this, 6 months. And the sales team sold an average of 15 cars per week for that same time. During the first 6 months, which of the following equations best models the car inventory C at the dealership T weeks after opening? So it's 29 is the starting inventory, and then it's plus 3W because you see we're selling 15 cars a week, but we're gaining 18 cars a week, so it's a net positive of 3 cars per week. And they want T weeks, so it should be T, not W. C equals, I think that's it. It feels kind of easy for a 19, but I just want to make sure I didn't make any mistakes. Hold on. Had inventory during the first 6 months, 18 cars were purchased each week, and the sales team sold an average of 15 cars per week. So it's 3. Net 3 plus. Inventory C. So it starts at 29. So they all have 29. And we're gaining 3 per week. T is T weeks. Okay, we got it. I just make sure there's no mix up with days or anything. All right, this one. 2 radical 2x equals A. What is 2x in terms of A? Immediately, I'm going to square both sides. 4 times 2x equals A, and then we want to isolate 2x. Let's not even do anything fancy. Just divide both sides by 4. Cancel, cancel. 2x is A over 4. It's not there. Oh, I forgot to square the right side. My bad. Let me fix my mistake. Square this side as well. Good thing they didn't have it. I would have been in trouble. Now we divide by 4. Now we divide by 4. And 2x equals A squared over 4. Just make sure that works. If I plug in A squared over 4 for this, times 2, A squared, that's the square root of that is A over 2 times 2, cancel, and it's A. Boom, works, done. 21, arrangement 1, arrangement 2. Okay, let's write down these numbers just in case they need that. 8, 12, 13, 14, 18, 20. So we're going up by 6 every time, it looks like. A project coordinator banquet hall is giving a task of seating arrangements for award ceremony. Figure above shows the first 3 possible arrangements of tables and the maximum number of seats in each arrangement. If the number of seats in every successive arrangement increased by 6 over the preceding arrangement, which of the following represents the maximum number of seats around end tables? All right. So this is an arithmetic sequence, and people ask me, do you need to know the formulas? Nah, you don't, but it's not bad if you know them. So it's A sub n equals the first term in this case, which is 8, plus the common difference, which is 6, times n minus 1. And this will give you the formula, which is pretty neat. It's 6n minus 6 plus 8, so it's 6n plus 2. And let's see which one of those has it. It's this one, because what they did then is they factored a 2 out and got 3n plus 1. And now we can check it. So which of the following represents the maximum number of seats around end tables? So for example, if I have 2 tables, I should have 14. Like I said, plug 2 in, that's 6 plus 1 is 7 times 2 is 14. If I have 3 tables, I should get 20. 3 times 3 is 9 plus 1 is 10 times 2 is 20. So it works. Did you need that? Man, you could have also plugged in and all that, but it's pretty nice if you have it down. 22, the graphs in the xy plane of the following quadratic equations have x-intercepts of -2 and 4. The graph of which has its vertex farthest from the x-axis. Okay. They're all -2 and 4. Oh, snap. It's... Got it. Okay. I understand now. So the x-intercepts are all going to be at -2. Hold on. I have to think about this for a second. So it's going to be at... They're all going to be at -2, right? And 4. Which means the vertex will all be in the middle of this where x is 1. So all I got to do is plug in 1 and see which y value is the farthest away. So if I plug in 1, because the vertex is always in the middle of the x-intercepts. So that's 3 times -3 is -9 times -7 is 63. This is probably the winner. Let's plug this one in. 3 times -3. Oh, it's always going to be -9, right? -9/10. That's definitely out. That's not that far from the x-axis. But that seems too obvious, doesn't it? But it's right, I guess, because it's a vertical stretch. It's a stretch of the most, so it pushes it up the most. This one would be -9/2, or sorry, this one would be 9/2. So 3.5, and then this one would be, again, -45. So this is almost the winner, but it's A. Yeah. Weird question because I haven't seen many like it, but it's pretty cool. Okay, then we've got this. The system equation above C is accounts for what value C? Will there be no solution? AKA, these guys are parallel. Immediately, I'm going to slope-intercept form for the top one. It's -2x plus 5. Divide by 3, y equals -2/3 x plus 5/3. Bottom will become cy equals -4x plus 8. Y equals -4 over cx plus 8 over c. No solution means these guys will have different y-intercepts, which I'm pretty sure they y-intercepts, and the same slope, aka -2/3 must equal -4 over c. And now we solve for c. Cross. -12 equals -2c. Divide by -2, c equals 6. Boom, done. Now we're going to double check. Plug in c there. 4x plus 6y equals 8. 6y equals -4x plus 8. Divide by 6. Y equals, and then -4 divided by 6 is -2/3 x plus 4/3. -2/3 slope. -2/3 slope, we're good to go. And different y-intercepts, but it's almost like it has to be, otherwise this thing doesn't work. So the polynomial p to the 4th, 4p cubed, 3p squared, but whatever, it can be written as this. What are all the roots of the polynomial? +1, it's where this zeroes out. +1, -1, and -2. 1, -1, -2. I wrote in the wrong order, but -2, -1, and 1. Done. Basically it. Because they give you the factored form, you don't have to factor it. And, 1 and -1 zero this guy out. -2 zeros that guy out. That's pretty much all there is. All right, 25. Which of the following describes an exponential relationship between the pair of variables listed? For every 3, what? What variables? Oh, got it. It's in the problem. Okay, for every 3 millimeter increase m in the thickness of a piece of glass, the intensity of light. Actually, I think it's A, because if it's decreases by 20 by a percentage like that, or increases by a percentage for a constant change here, it's exponential. But let's keep going. Decreases at a constant rate of 10. Nope, that's linear. With every 33-foot increase in depth below surface water pressure on an object. Nope, that's linear. 3314. The depth of water remaining as a reservoir decreases 15 minutes. Yep, that's linear as well. Boom. Moving on to 26. Researchers investigating the in 26 and 27 refer to this. So researchers investigating the relationship between the price of a 4-pack of AA batteries at a convenience store and the number of competitors the store has. She defines the store's competitor as another similar store within a 1-mile radius. She defines the a store's competitor as another similar store within a 1-mile radius of the store. She selects 32 convenience stores across the state. Wait, hold on. And the number of competitors the store has. Got it. She selects 32 convenience stores across the state at random for each store. Oh, got it. She records the number of its competitors and its price. Okay. The number of its competitors and its price for a 4-pack of batteries. Results are shown with the line of best fit. So, got it. The pricing is higher if you have, when you have more competitors, the pricing drops. That makes sense because if you have more competitors, you need to have more competitive pricing. Less competitors, it's higher up. It goes up to $6. Here it's as low as like $3.20 or whatever. Another convenience store in the same state sells a 4-pack of batteries for $4.89. So that would be like here. Let's just draw a line in case we need it. I'll do it in a different color. Okay. If the store's price is more, wait, another convenience store in the same state. Got it. If the price is more than that predicted by the line of best fit, aka it's got to be over here somewhere where it's above the line of best fit. What is the least number of competitors the store could have? I'd say 3. Because 2, it's above. You get what I'm saying? Because that's 420, 440, 460, 480, 4989, whatever. And so it's nice that we can draw this really nice line here. But you can see that 5 is about, it's hitting there at 5 about. So it must have at least 3 competitors. Okay, because at 3 it's below, 4 it's below, 5 it's below. 27. The line of best fit passes through the point in 18 negative 0.12, which is fine, can be concluded from this. Hold on. That means here at 18, it's going to have a negative price. Obviously, that doesn't make sense. The line of best fit will no longer model the price well for a store with large number of competitors. I agree with that. But hold on, let's just put an arrow for now. Let's read the rest. A convenience store with 17 competitors can no longer sell. No. Well, I mean, it just doesn't model it. It doesn't mean they can't sell it. 17 cannot decrease its price any further. No, not necessarily. A convenience store cannot have more than... No. It just means the line of best fit's no longer valid. 28. The figure above shows that the shaded triangular region with a hypotenuse of 5. Got it. So that means this is a right angle, of course. And this is a right angle because they're all 30. Has been removed from a rectangular tile with dimensions x by y. Got it. X by y. Of the following, which best approximates the area of the tile before the piece was removed? Now, this is a giant puzzle. If this angle is 30, this angle over here is, this angle over here is 60, right? It's a 30, 60, 90. That means this angle up top is also 30, is a 60, because 60 plus 30 plus 90 is 180. And this is also 60. It's a bunch of 30, 60, 90 right triangles. If this is 60 and this is 60, this whole thing is 180. Guess what? This is also 60. And guess what? This is also 30, okay? So that means that we got a 30 by 60 triangle in all of these. All right. Now we can start to figure out what all these are. Hold on. Let me think if I can do this. So we just need to get X and Y. So if that's 5, this side over here is 10 because it's the smallest side times 2 gives me the hypotenuse. If that side is 10, and then over here, this side right here is 5 rad 3, right? If you remember from 30, 60, 90, it's little guy times rad 3 is the medium. Little guy times 2 is the big dog, the hypotenuse. Now, if this is the hypotenuse of this one, this would be divided by 2, 5 over 2 rad 3. I might be doing way too much work, but that's okay. And then this side, y, is the small side times rad 3, which is 5 halves times rad 3. Rad 3 times rad 3 is, of course, 3. So it equals 15 halves. So now we know what y is. What about x? If this is 10, the little guy is 5. Wait a minute. How can those two be equal? That doesn't make sense. What did I do wrong? 5. That's 30. How can that be? And double is 10. Huh? How can these oh, I guess they are equal. They are equal. That's so weird. Yeah, they're just opposites. Okay, so then this is 5 rad 3 over here. Huh. It's crazy. Crazy town. Yeah, because they share a hypotenuse. So then the area of this whole thing before they remove that is 5 rad 3 times 15 over 2. So 7.5 times 5 rad 3. $65. Okay. And then I guess we don't really need to do anything else to verify. I feel like I did that right, but now we can approximate. If I know that's 5, and I mean, it doesn't say it's not drawn to scale, so maybe we can kind of assume it is. I really don't like to do that, but let's kind of see if this makes sense. And then This side is going to be half of that, which is 2.5. That makes sense, right? That this side is 2.5 and this is 5. So that does feel 7.5, feels 100% right. And then this side x looks a little bit longer. So let's just pretend like what's 7.5 times 7.5, even if we don't, have it exact. So 56.25. So, and it's probably bigger because 5, it looks like it's longer. So 5 times radical 3 was like, yeah, it's about 8.5. So I feel like we got this. It's a pretty darn hard problem, I'm not going to lie. 29 is Thomas is making a sign in the shape of a regular hexagon, 4-inch side. So regular means all the sides are, of course, equal. 4, 4, 4, 4, 4, right? And he will cut out from a rectangular sheet of metal shown in the figure above. What is the sum of the areas of the 4 triangles that will be removed? Got it. Okay, let me think about this for a second. These are right triangles. Right triangles. So now it's a hypotenuse of 4. Hypotenuse of 4. And okay, hold on. 4. And then for a hexagon, all these angles are it's 6 minus 2 times 180. That's the sum of all the interior angles. I said it's regular, so all the angles are the same, and then divided by 6. So that's 4 times 180, which is 720, divided by 6 equals 120. So this is 120 degrees. That's 60, and that's 30, okay? And so the hypotenuse is 4, so that means that little side is 2, and this side here is 2 rad 3. Okay. So what is the sum of the areas of the 4 triangles? So look, these 2 triangles make a rectangle, and these 2 make a rectangle. So it's 2 times 2 rad 3 is 4 rad 3 for the bottom 2 together as one rectangle. I'm not taking half and then adding because what's the point? And this would be another 4 rad 3. Oops. 4 rad 3, add them together, and we get 8 rad 3. Okay, let's just make sure that makes sense. So 4, we said that's 2. That feels accurate. And then if it is 30, 60, 90, 2 rad 3, so that's 8, 2 times 2 rad 3, 4 rad 3, 2 rad 3. So times 4, 8 rad 3. Yes, feels good. Last problem for the multiple choice, which has been quite hard, I have to say. Which of the following equations describes a circle with radius of 10? You're out because the radius has got to be, this has to be 100 because it's the radius squared. That passes through the origin. What? Oh, when graphed in the xy plane. Sorry, the point passed through the origin. So that means 0, 0 is on this circle. So for which one of these can I plug 0, 0, 0, and 0 in for x and y and get a true statement? Not here, because this would be 25 plus 25. It would be 50 equals 100. You're out. This would work because it'd be, no, this would not work because this would be a 10 squared, which is 100 plus 100. There would be 200 equals 100. You're out. It's got to be this one. But it would be 5 square root 2, because it's 0, negative 5, but it doesn't matter because it's squared. 5 square root 2 squared is 25 times 2, which is 50. 25 times 2, which is 50, and that indeed equals 100. Numero 31 with 19 minutes to go. 8 questions left, and we're on the free response. Now it's going to get chill, so we always look forward to this part because it's a relief, and the difficulty should drop, and you should expect that. In the xy plane, the graph of this is the image of this after translation of how many units to the right. So here, the vertex is 6, 3, right? Because it's in vertex form. Here, the vertex is negative 5, 3. So going from negative 5 to 6, that's a translation of plus 5 and then plus 6, which is 11. And that's it. You can graph it because if you have a graphing calculator to verify, but that's 100% all you need to do. When 9 is increased by 3x, aka plus 3x, the result is greater than 36. What is the least possible integer value for x? Let's solve. 3x, subtract 9 from both sides. 3x is greater than 27. Divide by 3, divide by 3. X is greater than 9. So it can't be 9 because it says it's got to be greater than 36. So it's got to be 10. Okay, so now let's double check. When x is increased by 3x, so if it were 9, it would be 3 times 9 is 27 plus 9 is 36. It wouldn't be greater than 36, so it's got to be 10. One more than that, okay? So the inequality there was very important. 33, century and region of United States presidents' births as of 2014. The table above shows a distribution of United States presidents according to the century and the region of the country in which they were born. Hold on. Got it. Okay. So Northeast in the 18th century, most people were from the South. In the 19th century, most people looks like we're from the Midwest. Go Midwest. That's where I'm from. And then in the 20th century, I wonder if this is true. It looks like a mix: Midwest, West, Northeast, South, all that. Okay. Wait, what? What's the question? Oh, I didn't even read it. Distribution of the United States presidents according to the century and region. Okay, based on information. What fraction of presidents who were not born in the 19th century were born in the South? What fraction of the presidents who were not born in the 19th century? So I can almost ignore that, right? I'm not going to cross it off so you can see it, but what fraction of presidents who were not? So we're only dealing with this. So it looks like there's 14 and 6 plus 4 is 10. There's 24 that were not born. What fraction of presidents who were not born in the 19th century were born in the South? So it looks like 3 and 9, which is 12. So it looks like 1/2. Now, I've previously said that you got to reduce the fractions on the College Board. Somebody corrected me and said you actually don't. They showed me the College Readiness Guide. You actually don't have to reduce them all the way. It's as long as the fraction fits in the grid, you're okay. So I guess theoretically you could put like 3/6 or whatever you want, but I reduce it anyways. But I do think if you're in a time crunch and it fits unreduced, I do think that's it's fine. But I don't know. I got such a habit of reducing. X does not equal -1. What is the value of this times this? Okay, so we're just going to distribute and basically, actually, this just jumps onto the top. So it becomes 2 plus 2x over x plus 1. Now, you know, if this is for your response, it's got to reduce to a number. How do we do that? Factor, 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 right? I always say when in doubt, just factor. So it becomes 2 times 1 plus x over x plus 1. I can rewrite that because that's commutative property. 1 plus x is the same as x plus 1. These guys cancel, and we get 2. And that's it. Now we're just going to double check. Now this means I can plug in anything for x and I should get 2. Let's plug in 10. So 2 plus 20 is 22. 10 plus 1 is 11, and we do indeed equal 2. 35. The price of a ticket to a play is based on the row the seat is in, as shown in the table above. A group wants to purchase 10 tickets for the play. They will purchase 3 tickets for row 1. They will purchase 2 tickets for row 3. They will purchase 2 tickets for row 4. And they will purchase 3 tickets for row 12. What is the average ticket price in dollars for the 10 tickets? Got it. Okay. So 3 here is 75. 4 here is 80. 3 here is 45. So we're going to add them up. I know I have a calculator, but I'm just going to do it like this for fun. So that's 10 plus 1 is 8, 16, 20. And then that's 200 divided by, let's just make sure it was 10 tickets. 5, 10, yep. So it's $20. And that makes sense. It's kind of in the middle of all of these. So there you go. Just make sure I didn't make any mistakes. 3 tickets in row 1. 2 tickets in row 3. 2 tickets in row 4. Both in here. That's 4. And then 3 tickets in row 12. Let's say, yo, what's up, Coop and Camp? I know you guys are watching. Anyways, all right, so we got 75, 80, which I got, and 45. So I feel like we checked the numbers. We're good to go. All right. 36, a fashion buyer for a large retail store purchased 315 items directly from the manufacturer for a total of $6,000. Fashion buyer for a large retail store purchased 315 items directly from the manufacturer for a total of $6,000. Okay. Some of the items were dress purchases for 25 and the rest were shirts for 10. So dresses for 25 and shirts for 10. Okay. How many more okay. This is a system of equations, right? And we got 2 things. We know that and D is the number of dress, D is the number of dresses, S is the number of shirts. So I know the total S plus D has to equal 315. And then I know that if I now get this in terms of value, 25 per dress plus 10 per shirt. I know I hate S as a variable because it looks like a 5, but let's just roll with it. This has to equal 6,000. All right. Now we can use a little substitution, and we need to solve for both of these because I need to know how many more dresses than shirts were purchased. So I'm going to arbitrarily, actually, no, I'm going to use elimination because I like that much better. I'm going to multiply the bottom by -10. So we get, and flip these around so the D's and S's are lined up. So I got -10D minus 10S equals negative 3150. Notice I multiply each and everything by negative 10. Now we're going to combine. I'm going to move that. Actually, no, I'm not going to move it. We'll just roll with it and move past it. So those cancel. 25 minus 10D is 15D equals 6,000 minus 3150 is 2850. Okay? And I did that mentally, but I'm pretty sure that's right. Now we're going to divide by 15, divide by 15, and I get 2850 divided by 15, which equals 190. So they bought 190 dresses, and since the 2 add to 315, the number of shirts should be 125, right? 125 plus 190 is 315. So the difference is 65, okay? So I'm going to put that in, but I'm going to double check my work now. All right. So I know that this has to, of course, these add up to 315, but does it satisfy the other one? What's 25 times 190? Plus 125 times 10, which is 1250. If this adds up to 6,000, I'm good, and it does. So I feel confident. I'll just double check that last subtraction. Wait a minute. Yeah, I did it right, I think, but 65, we're good. 2 questions left, and 2 questions left here is 11 minutes to go. An instrument shows the number of revolutions per minute made by each tire of a car. Shows the number of revolutions made by each tire of a car. In each revolution, the car travels a distance equal to the circumference of one of its tires. An instrument shows each revolution, the car travels a distance equal to the circumference. Okay, makes sense. Circumference of each tire is equal to 2. Of course, that's the circumference. Okay, if the radius of each tire on Maria's car is 0.3, what is the approximate speed of Maria's car to the nearest kilometer per hour, when the instrument is showing 779 revolutions per minute? That's like the speed, right? Okay. So I don't like that this isn't. So I'm going to turn, let's see. I'm going to have to turn this into the circumference into kilometers, unfortunately. So we're going to have to divide by 1,000. So that's a bummer because it goes 1, 2, 3. So it's going to be a really crazy decimal. And I'm going to use distance equals rate times time. So I got 0.0003 kilometers times, so 2 times this times pi, 2 pi r, 2 r pi in this case. That's the circumference, okay? Hold on. And then this is to the nearest each tire. It's going 779. So then it's this times 779. That's in a minute, right? So it's like circumference times the number of revolutions that'll be the distance it goes in 1 minute. So let's get that. And we need nearest kilometer per hour. So hold on. 779.000 times pi equals. So that's per minute, and then per hour is that times 60. So then it's 88 kilometers. Wait, hold on. That's distance per minute, which is basically speed. And then, yeah, it's just 88 kilometers per hour. We don't need the units. This is I just want to make sure I didn't make any mistakes. This is a lot of weird stuff. So the radius is 0.3, 2 pi r. That's right. So it's 0.0006 pi. And then times 799, and that's per minute. So that's the distance per minute. And then you get the distance per hour multiplied by 60. Yeah, I think that's good. Okay, and then 38. Maria gets new tires for her car. The radius of her old tires is 0.3, and the radius of new cars is 11% greater. So that means I take 0.3 times 1.11. That gives me the 11% increase. So now they're 0.333 meters. What is the circumference of each new tire to the nearest 10th of a meter? So it's that times 2 times pi. So now it's going to be to the nearest 10th. We round up to 2.1, and we're done. And that's it. So I think we got everything. I think I got everything right. And now we're going to check. But that was a really hard test, I think. I don't know. I want to see what your thoughts are. Let's get the answers queued up. Okay. Okay, numero uno, we got CADC. CADC. Obviously, when you have extra time, hold on, how much extra time? Yeah. You should go back and check your work. I'm not doing that because we're just, of course, doing this for you guys. If I did make any mistakes, we'll go over them. And then 5 is CDAB. CDAB. Number 9 is BCAC. BCAC. 13 is BCBD. Good. Halfway point of the multiple choice, so far so good. Number 17, DBDB. DBDB. Excellent. 21 is BADC. So far, so good. Now we get to the last 6, which are really hard. ACAD. ACD. Yes. And 29 is A and D. All right. All those were good. Now we get to the free response, a little tougher. Make sure I didn't make any stupid mistakes. Hopefully not. 11, 10, 1/2, 2, 20, 65. Yeah, looks like 88 and 2.1, or they also accepted 21 tenths. Baller. All right, we did it. Let's see the questions and comments and what we got here. If you guys did like this video, please click that like button. That was hard for me, and I was focused and giving it my all. So if you did like this video, please click that like button. It helps tremendously. All right, let me see what we have. Cooper. Coop, legend. It's asking per hour is in per minutes. That was, can you go over 31? Sure. And 37. Okay, I'm going to do my best because I have appointments coming up pretty soon. 31. Okay, look. Here's the dealio, all right? This is in vertex form. So that's what I put up here was the vertex. The vertex is the opposite of this, 6, and then that, which is 3, 6, 3. Here, the vertex is -5, opposite of that, +3. So it's a translation, just looking at the vertex, the vertices of the two things, you're translating it literally from -5 to 6. That's a move of +11. That's it. And then 28. You asked for what to do the morning of the SAT. I have a video for that. Here, let me send it to you. It's this one. This is the new one. Here you go. Yo, what's up? Assassin's Bounty. Let's see who else. What were you asking about? 28. Okay, 28. Look, here's the deal with 28. Does it make sense that somebody if they have 18 competitors in a square mile, does it actually make sense that they're going to price batteries at -12 cents? Like they're going to give you money to buy batteries? No, of course not. That doesn't make sense. So there's a point with all these models that it just doesn't make sense. You could think about YouTube growth. Like I can graph my growth with an exponential function, but it doesn't make sense after a certain point because if you go out long enough, the number of subscribers you predict will be greater than the population of the world. That's exponential growth, right? It just goes up forever. So even if an exponential in short term models it correctly, eventually it just doesn't hold water. So it's the same with this. That should tell you that if you're predicting a price of -12 cents, it's obviously no longer valid for that many competitors. Yeah, 37 is like this, okay? 37 was definitely hard. But it's like this, okay? All we need to do is I'm just basically trying to figure out the amount of distance I'm going in 779 revolutions and in kilometers. If I did it in meters, I've left it at 0.3. But first I had to convert it to kilometers because I want this in kilometers per hour. So I converted 0.3 to 0.0003. That's 0.0003 kilometers. Then I put it into the circumference formula, which is 2 pi r. So then I get the circumference, whatever that is. So every revolution, I'm traveling that distance. So then I say multiply by 779 because that's the revolutions per minute. So in a minute, I get whatever I got there. Then I need to know for an hour. So I'm already in kilometers. I have kilometers per minute. Now I want per hour. So I multiply it by 60 again, and that's how I got 88. Okay. Maxu, you're welcome. Shahir, you're welcome. All right, guys. I really got to go because I got an appointment coming up, and I should probably eat something. Zoe, you're so welcome. Zoe, I know you got your test tomorrow. Oh, and thanks for all the likes, guys. I appreciate that. Those really help the channel. Zoe, I know you have your test tomorrow, so do let me know in the comments, or you're welcome to email me and just let me know how it goes for you when you actually do take it. And I wish you the best of luck. Thank you for all the support, and thank you for jumping on all these live streams and participating and commenting and all that stuff. Let's see. Goop Camp, you guys. All right. Let's see. Okay. All right. Anyways, for those of you guys who are asking about what to do the day of, I sent the video. Check that out. That's it. Thank you guys so much for joining. You're welcome, Tiff. You're welcome, Oswaldo. Baran, you're welcome. Toby, you're welcome. Lucas, you're welcome. Thank you guys so much. I got to run. Sorry, I have a busy day, but I'll be back doing streams tomorrow and tomorrow and Thursday. I'll see you guys next time. Take it easy.